Good morning, children. So welcome back to the online session of our physics class. We are discussing about the lesson, motion lesson. So in that, we are discussing about the concept acceleration, which is a rate of change of velocity, right? So which is changing of velocity with respect to time. So in the previous videos, we have learned about what is acceleration and when it will be a uniform and when it will be a non-uniform acceleration. Okay, and we have discussed about some of the examples, some of the situations where the acceleration is uniform or where the acceleration is non-uniform. So, and then we have solved one example also. So, which is a situation where we should find out the acceleration in two cases. In the first case, in the second case. That means Rahul pedals a bicycle from a stationary point to some velocity. That is, initial velocity is 0. Then final velocity will be attaining some velocity 6 meters per second in some 30 seconds. Okay, so that is first case. In the first case, we should find out the acceleration. What will be the acceleration over there? They will be increasing the velocity. That means is applying the velocity in the direction of the motion. So therefore, the acceleration is positive. Okay. So in the next case, what you will do, you will apply the brake in such a way that you will be bringing the velocity from 6 meters per second into 4 kilometers per second, right? In 5 seconds. So there, you will be giving the acceleration in the opposite direction of the motion. There it will be acceleration will be negative in the second case. We have observed that it is negative in the second case. That means acceleration, we will be applying the acceleration in the opposite direction of the motion. Therefore, acceleration is negative. So basically, what it will be acceleration? It is a rate of change of velocity. When there will be uniform motion means there is no change in the velocity. Velocity will be a constant. The rate of change of velocity will become a constant. If the velocity is same in all the intervals, then there is no rate of change. There is no change in velocity. So therefore, rate of change of velocity will become 0. So when there will be a non-uniform motion, so their velocity will be increased. Sometimes it is increases, sometimes it is decreases. So there will be a existence of acceleration. So to understand the changes, sudden changes of velocity, we will be come with a new physical quantity, that is acceleration. Okay, that is what we have learned. What is acceleration? And SI unit of acceleration is meter per second square. It has to be in meter per second square only. The SI unit of acceleration is meter per second square, and acceleration is change in velocity divided by time. Mathematically, it is called as v minus u by t, where v is final value of the velocity, then u is initial value of the velocity, t is the time taken. Okay, so if you find out that, you will get the acceleration. So these are the things they have learned in our earlier class. Now in today's class, we have some questions. So we'll solve those questions and we will go for the next concept. The questions are: when will you say that a body is in uniform acceleration, non-uniform acceleration? The first question is, when will you say that a body is in, first one, uniform acceleration, second one, non-uniform acceleration. So when we say that a body is in uniform acceleration, non-uniform acceleration, I have given the example of uniform acceleration and non-uniform acceleration. Uniform acceleration in the sense its velocity will be changing in equal amounts by equal amounts in equal interval of time. So velocity is changing. Velocity is changing in the sense acceleration exists. Velocity is changing in such a way that it's changing like equal amounts in equal interval of time. Okay, so that is uniform acceleration. Non-uniform acceleration, example of uniform acceleration is freely falling body. It will change in the velocity by equal amounts in equal interval of time. Non-uniform acceleration, the example will be a vehicle traveling in a crowded road. So that is the example for the non-uniform acceleration. Their velocity is not changing uniformly. Sometimes it is increases, its speed will be increases, sometimes its speed will be decreases. So okay, so therefore there will be a non-uniform acceleration. Now, when will you say that a body is a uniform acceleration? Generally, when will you say that a body is a uniform acceleration? So when will you say that body is an uniform acceleration? The answer is, a body is said to be, for first one, for uniform acceleration, a body is said to be in uniform acceleration. A body is said to be in uniform acceleration if it travels in a straight line. It travels in a straight line. Okay. A body is said to be uniform acceleration if it travels in a straight line in such a way that its velocity changes in a uniform way. Its velocity is changing. Velocity changes in a uniform rate. That is velocity either increases or decreases. Both are changes only. Either it may be increases or it may decrease also. Increases or decreases by equal amounts in a equal interval of time. In a equal interval of time. Okay. So in this situation, we will say that the body is in uniform acceleration. When we say that the body is in non-uniform acceleration, the body is said to be uniform acceleration if it travels in a straight line. In such a way that its velocity changes in a uniform rate. Its velocity changes at a uniform rate. That is, velocity increases or decreases by equal amounts in an equal interval of time. Okay. So what I explained for uniform acceleration, I am returning statement for the second one. When we say that in non-uniform acceleration, the body is said to be in non-uniform acceleration. Okay. If it travels in a straight line, otherwise I'll make a change here only. Okay. I don't want to waste the time by writing this. I'll make a changes for the second one also. This is for the first one. Write the answer for the second one also. A body is said to be in non-uniform acceleration if it travels in a straight line in such a way that its velocity changes at a non-uniform rate. Wherever they are uniform, they will need to apply non-uniform. Okay. How it is? That is, velocity increases or decreases by not equal amounts, it is unequal amounts. its velocity changes at a non-uniform rate, that means either increases or decreases by unequal amounts. In the first second, its velocity may be 40 km per hour. In the next interval, it will be 60 km per hour. In the next second, again it will be decreases to the 10 km per hour. That means its velocity, of course it is changing. The velocity is changing. First it is 40, then it is increased to 60, then again it is decreased to 10. So that means the velocity is changing not in the uniform rate, right? 40 km initially, then 60 km per hour, then 10 km per hour. Okay, so initially it is going at 40 km, then after next interval it is at 60 km, and the next interval it is at 10 km per hour. Changes is 40 to 60, 20, then 60 to 10, again there will be changes 50. Observe that its velocity is not changing at a uniform rate. It is changing at an ununiform rate, that is not uniform rate, right? So it increases or decreases by unequal amounts. Unequal amounts, equally, time will be equal. Time will be first second, third second, fourth second, fifth second. Time will be same, interval will be same. But the quantity is changing like unequal. It is not equal amounts. Whereas in uniform motion, it is changes at a uniform rate. Okay? So next we will go for the second question. The next question is, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Okay, here the speed is, that means velocity is changing from 80 km per hour to 60 km per hour in 5 seconds. At that instance, what will be the acceleration that we need to find out there? Okay, so while finding the acceleration, what are the values required to find the acceleration? We need initial velocity, we need final velocity, and then we need time. If you know these three quantities, we can easily find out the acceleration. But very important is, acceleration unit must be whatever the value, numerical value, magnitude, unit must be meter per second square. It has to be in meter per second square, right? It should not be in kilometer, it should be in meter per second square, correct? Now, so in the question, they are given its speed decreases its speed from 80 km per hour to 60 km per hour. Vehicle will be going at 80 km per hour. So it will be decreases its speed by applying the brake. So it will come to 60 km per hour in 5 seconds. In 5 seconds, find the acceleration of the bus. So what would the initial velocity here? Obviously, the initial velocity is 80 km per hour, right? Because it is decreasing. 80 km per hour is the initial velocity. 60 km per hour will be the final velocity. So you can make a note of that. Initial velocity. Initial velocity u is equal to 80 km per hour. Okay, 80 km per hour. Or otherwise you can write 80 km h inverse. Both are same. Writing like this: kilometer per hour or kilometer per hour or kilometer h inverse. These three are same. All these three are same only, right? Kilometer by, that means kilometer per hour, kilometer per hour, kilometer per hour, kilometer h inverse. That means if h will be, if you are taking h to the denominator, what will happen? Kilometer, nothing in this is power will be 1. If you are taking to the numerator, it will become, power will become negative. So that is this. So this kilometer per hour can be written like numerator denominator combination also, or otherwise you can write like this also. These three will be same. Okay. Now it is given in 80 km meter per second. Okay, we have given it kilometer per hour, convert it to meter per second. So 80. Okay, so this is kilometer and we are converting it to meter. Kilometer to meter. So I should multiply with 1000, right? Denominator per hour. We should convert it to second. So 1 hour is for how many seconds? 3600 seconds. Right? Now it is in meter per second. Initially it was in kilometer. I have multiplied with 1000, therefore it is in meter now. In the denominator it is in R. I have converted it to seconds, so therefore 3600 seconds. Okay. Now 20 will get cancelled. What is remaining? 80 into 10 divided by 36. Okay. So I can cancel it. 2 5s are. Okay. Then 2 18s are. 2 5s are. Then 2 18s are. Again I can cancel because I am having 80 and then 18. Right? 2 9s are. Then this is 2 40s are. Right? So what is remaining now? 40 into 5. In the denominator we have 9. Correct? Now 40 into 5 will become 200 by 9. So divide 200 by 9. How much you are getting? 9 2s are 18. 2 will be remaining. 2 is 0. Again 9 2s are 18. Again 2 to the point 0. 9 2s are 18. Again 2 0. 9 2s are 18. It is a irrational number. It is keep on going like this. Also, it is a rational number only because it is a recurring. Okay, so it is keep on like this. So in the physics, if you want to take it after the decimal point, you can take 2 digits. That is enough. So 22.22 meter per second. So this is initial velocity u. Initial velocity u is equal to 22.22 meter per second. So we write the final velocity now. Okay. So this is initial velocity is done. That is u is equal to 22.22 meter per second. Initial velocity divided by kilometer per hour and convert into meter per second. If I convert into meter per second, I will get it to 22 meter per second. So final velocity. Final velocity v is equal to how much? 60 km per hour. 60 km per hour. Final velocity is 60 km per hour. Let us convert into meter per second. 60 into 1000 divided by 3600. So 20 will get cancelled. So what is remaining now? 60 into 10 denominator 36. Again 6 I can cancel from 660 also and then 36 also. 6 6 are 6 10s are, right? So what is remaining? 10 into 10 in the numerator, 6 in the denominator, right? So again I can cancel. 2 3s are, 2 5s are, right? So 5 into 10 in the numerator, 3 in the denominator. So 5 10s are 50, 50 by 3. So divide 50 by 3. You can get 50 by 3. 1s are 3. 2 will be the remaining. Take the next digit. So 3 6 are 18. Again 2. So put the point 0. 3 6 are 18. 2 0. We have to put the point. So 3 6 are 18. So again 2 is keep on going like this. So I can take after the decimal point. I can take 2 digits. So v is equal to 16.66 meter per second. This is final velocity. This is initial velocity. Okay. So it is given in kilometer per hour. We have converted into meter per second. Okay. Now initial velocity is 22.22 We'll use the acceleration. Time taken is 5 seconds. It's already in seconds. Okay. We'll take this. We'll write the acceleration formula. So initial velocity u is equal to 22.22 meter per second. Final velocity v is equal to 60.66 meter per second. Time taken is equal to time taken t is equal to 5 seconds. Correct? Now we know the initial velocity, we know the final velocity, we know the time taken. We can easily find out the acceleration by using the formula. What is the acceleration formula? So acceleration is equal to v minus u divided by t. Correct? V minus u by t, where v is 16.66 minus u is 22.22 divided by time. Time is 5. Correct? Now 16.66 minus 22.22, we need to subtract because one will be positive, another will be negative. So this is the smaller value and this is higher value. Subtract the smaller value from the higher value. 22.22, 16.66. Okay. This is minus, this is minus and this is plus. Okay. Now subtract it. If you subtract 6 from 12, if we have it 2, we can't able to subtract 6. We need to borrow from here, so it will become 12 and it will become 1 now. So 12 minus 6 will become 6. Here we are having only 1. We can't able to subtract it. We need to borrow from here. So what will happen is 11. So 11 minus 6 will become 5. Correct? Now the point is same. Here we are having 1 because we have given 1 over there. So again we can't able to subtract 1 from 6. Again we need to borrow from here and it will become 11. 11 minus 6 will become 5. Correct? Here we have already 1. 1 minus 1 will become 0. Correct? So it is 5.56. Correct? 5.56, but the sign is negative because the other value is sign. Between 22.22, 60 and 66, 22.22 will be having the higher value. Before that we are having a negative sign. Therefore it is negative. So what is the answer? Minus 5.56 divided by 5. Okay. So what we will do? We need to divide this 5.56 divided by 5. What we will do? We will multiply with, since we need to remove the decimal point. We will do like we will multiply with 100. Multiply the numerator and denominator with the 100 to remove this decimal point. So what will happen? Minus, since I am having a point here, when we multiply with 100, so 2 0, this decimal point will be placed here. So 556. In the denominator, 5 into 100 will become 500. Okay. So now we will divide 556 by 500. 556 divided by 500. So 500 ones are 500. Correct? Remainder will be 56. Put the point 0. Again 500 ones are 500. Correct? So the remainder is 60. Again we have to put the point 0. So again 500 ones are 500. Again the remainder is 100. We already put the 0, so I will give him one more 0. So 500 twos are 1000. Okay. Now it is 1 point minus 1.112 meter per second square. This is acceleration. Acceleration is minus 1.112 meter per second square. This is the unit of acceleration. So it is in minus. Why it is in minus? What indicates this minus? This minus indicates that velocity is in, acceleration will be in the opposite direction of the motion. Observe that bus decreases its speed. decreases its speed. That means to decrease the speed we need to apply the brake. So in this case we are applying the brake. Initially say going at 80 kilometer, to bring it to 60 kilometer we need to apply the brake. That means acceleration we are giving in the opposite direction of the motion. Therefore there will be a negative sign in the acceleration. Okay. So this is about the second question. So you can go for third question. A train starting from a railway station and moving with a uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. That will be the homework for your third question. Third question. It is also there also you should find out the acceleration. We have given the initial speed. You can easily find out the initial speed because the train will be starting from a stationary point. You know that when it starts from a stationary point, what is the initial velocity? So it will attain say 40 km per hour in 40 minutes. So you know that time, convert into seconds because it is given in minute, convert into seconds. Again 40 km per hour, final velocity, it is kilometer per hour, convert into meter per second. Then you know the acceleration formula, v minus u divided by t. So you substitute it and get the acceleration. Okay, so that will be the homework for you. So that's it for today's class. We will go for graphical representation of the motion that we will discuss in the next video. Okay. Thank you. Any doubts for the today's class, you can get back to me to my WhatsApp number or otherwise